We have an extensive range of products coming from, so we wanted to bring that forward. We talked a lot to installers, we talked to people in the back office, trying to get something that could take us a notch forward from where we were.
That's fantastic. Patrick, from a product management perspective, what type of design approach did the guys in product management take for these solutions?
I guess broadly there were two angles. One is to get a fairly intimate understanding of the problems that users were facing with the products, to make sure that our next generation of meters address some of those problems, but also taking a longer term view on where the market was going and what sort of market problems were emerging and developing. Bearing in mind these products are typically in the field for 15 to 20 years, it's important to factor that into our design considerations.
Clearly, this solution can measure more, but where do we go from there? Like, can we move that data around, and how do we then process that data or understand that data?
That's where it's all going. The solar, the batteries, the controllable loads, all of these components need to be orchestrated, and that orchestration happens through the sort of data and the data speed combined with possibly edge intelligence or cloud intelligence to make sure that things are optimized.
So maybe give us an example, Ivan, of something there that we do in this solution that could help either the customers or the utilities?
Well, we've done things, we've sped up our backhaul to get that information back quicker, get more information back. There's a lot of local processing that we do, so it's not just a dumb meter, it is making decisions and so on. So in terms of things like hot water and switching in response to solar, we can do that sort of thing within the level of the meter without even needing to go back to a back office system.
Ivan's talked about those decisions at the meter, Patrick. What about in the cloud? What would be an example of how maybe some decision making at the cloud could be combined with what we're doing on the edge to solve a problem?
Sure. I guess a great example is the orchestration of hot water loads. So we're seeing more and more of that occurring, particularly in Australia. On the edge, the devices are configured to have controllable loads locally, and the state of those loads is getting transmitted into the cloud, and in the cloud, in response to, let's say, changes in the spot market or time of day, decisions can be made over whether that hot water gets turned on or turned off.
And what about like manufacturing quality? Are there things we're doing here with the NEOS lineup that might be a little bit different or improved from where we've been in the past?
Well, yeah, there's a lot we do with manufacturing. We have, in terms of the machines that test the meter, we are behind the software in those. So measuring accuracy, we measure thousands and thousands of data points on every meter, and the other testing the boards and at each stage of production, just to make sure that everything's within the limits it needs to be, there's nothing unexpected, and it's a consistent design.
There's a semi-automated line that goes into the manufacturing. Is that about making sure that the first meter and the 100,000th meter or whatever that number is consistently built in a way as per the design spec?
Yeah, it's all about consistency. So we're investing in automation in that space in terms of building the board. We've done a lot in the design of the meter to make that automation possible and to make it easier to put together.
Just talk us through that design thinking approach and what journey we took with the customers on the installation of the devices.
Well, yeah, we made a big point of going and talking to customers. We've got a lot of good feedback from there, like the size of the meter has been critically important, just being able to fit it onto site. Things like screws and terminal sizes and so on, to be able to easily fit wires. The way terminal covers work and so on, so you can bring in wiring, minimizing the need to drill new holes in a panel. All of these things add up to help save an installer time on site.
When you've got millions of these out there, you need to manage all the different configurations and all the different services that you want to offer. Is there anything in the system where we worked with customers to come up with a solution to that makes it easier for them?
Absolutely. I guess what's in the past, a lot of that complexity would have been delegated to the installers, but with the NEOS solution, all of that complexity is now handled in the back office. So there's a process whereby Certain meter configurations are approved for certain distribution networks, and then when the commissioning process completes, those meters are automatically reconfigured for that distribution network. So the load control rules, for example, on that meter are appropriate for that particular jurisdiction.
I think, all of this technology is about being able to, in real time, collect the data and be able to move that data quickly and effectively, and or provide access to that data to the different stakeholders that we've talked about, the end customer, the retailer for tariff arbitrage, the distribution business for an operating envelope around the network. And I think that's what we've built with the NEOS solution is this great technology that enables us using real-time data along with then the real-time control to be able to get that information to the right people and make those decisions as needed to be able to deliver for those different stakeholders.
For me, one of the great things is, the definition of real time starts getting more and more real time as time progresses. With your operating envelopes, real time is seconds, and as you start getting to when you're starting to maximize the utility from batteries, you're talking about frequency response, and you're down into milliseconds.
So looking forward 5 years into the future, how does NEOS help manage all of our customers' energy resources? So Patrick, how do you see it progressing?
Well, I guess the NEOS solution has three aspects. One is the device itself. The second part is the ability to add edge processing capability as an add-on. It's balancing this cost equation where we anticipate that in the future there is going to be a requirement for a lot more edge processing, but it's probably not something that can be justified right now. And then finally, we have the back end.
That's all scalable due to the cloud architecture.
Yeah, it's designed as a horizontally scalable, stateless architecture. It's a platform that's evolving constantly.
I guess we also have the other side of the story in terms of that control back out. So things like controlling loads directly and so on is a capability that's built into the meter. So it's not just monitoring things, it can also take those actions.
Yep, and similarly the back-end solution, Storm, has the ability to respond to those signals that are coming in from the various sensors, make decisions on loads that need to be switched, and switch those loads at scale. And as we kind of touched on earlier, if you can switch or move loads within 5 minutes, then you have certainty around the price for the next 5-minute interval. So there's huge economic benefits to being able to respond quickly and at scale. And Storm is a system that can handle that.
That's great. I think that's great for the end customer in terms of not really having to do a lot in terms of getting these benefits then, both to the customer and to the whole grid.